objects. So chirality, concept of chirality. I told you plane of symmetry, axis of symmetry, and center of symmetry. These are the three elements of symmetry. Elements of symmetry. And if elements of symmetry means if you have any one of these, the molecule is symmetric. If an object lack any element of symmetry, any of these three elements, any of the three elements of symmetry, it is achiral. Sorry, it's chiral. It is chiral. It is chiral or asymmetric, having no symmetry. Now, what is the peculiarity of chiral objects? Chiral objects, look here, this is very important. Chiral objects, the peculiarity is the mirror image is non-superimposable. Mirror image is non-superimposable. Non-superimposable. What is the meaning of superimposable? Superimposable means what? Okay, now see here, what is the meaning of that? Superimpose one over the other. Now let me switch out my video. I will show you. Yeah, some people are coming. Let them come for the one. Oh, Henna gets a connection very easy. It's all right, good. Henna's connection is gone, it seems. Okay, now see here. Look at my hand. If I keep a mirror here, if I keep a mirror on this side, and if you look at the image in the mirror, if you look at the image in the mirror, it will be this one. Am I right? This is going to be the mirror image of this hand. Okay? So that is the relationship between the two hands. They are mirror images. The two hands are mirror image. Now do one thing. Try to superimpose one above the other. Now, what is the meaning of superimpose? Look very carefully. Look at the four sides of this object, this hand. Four sides. This is one side. This is another side. Okay. This is a palm side. And this is a back side. Clear? These are the four different sides of this object. 1, 2, 3, and 4. Now, my left hand is the mirror image of the right hand. Do you agree to that? Do you understand that concept? Right hand is a mirror image of the left hand. If you want to have it, the same thing, just wait. I will bring a mirror. Now see here. I got the mirror here. And let me put my hand like this. See here. Can you see the image? Are you able to see the image? No. One second. Let me see whether I can. Oh, God. Are you seeing the image? See here. Now see. You can see the image now. See. Now let me show you the image like this. See the image in the mirror. See this. Now let me remove the mirror, and in that place I put my left hand. One second. Now see, can you see? Just one second. Just one second. I have, yeah, one second. Now you have seen, this was my object and this was the mirror image. So instead of my mirror image, I have put my left hand. Meaning the left hand is a mirror image of the right hand. Clear? Now see, as I told you, I have 4 sides. One side, left, right, front, and back. Clear? Left, right, front, and back. Now see, I'm trying to superimpose the same thing on my right, on this finger. Let me put my finger, the thumbs, and this on the same side. These two are matching. The two thumbs are matching. The little fingers are also matching. But look at the front and back. This front of this right hand is projecting towards you, but the front of the left hand is projecting towards me. So they are opposite. Similarly, the back side is also opposite. Now let me try to superimpose that front and back. Now see, both my hands, the front is towards you. Both my hands, the front is towards you. But look at the index finger and, the little finger and the thumb. The thumbs are opposite. See, the thumbs are opposite. And the little finger is also opposite. You cannot make all the 4 identical. That is what is called chirality. So the non-superimposable mirror image, that is a criteria for chirality. Okay, non-superimposable mirror image is a criteria for chirality. Organic molecules. For organic molecules, the non-superimposable mirror image. For organic molecules, if your mirror image is non-superimposable, that compounds are chiral. If the mirror image of an organic molecule, if for an organic molecule, if the mirror image of an organic molecule is, if the mirror image of an organic molecule is not superimposable the molecule on the original molecule, on the original molecule, it is a chiral compound. It is chiral. Now, how can you decide it? We have to explain this very thoroughly. I will bring the model and show it to you. Let me make simple methane molecule. Let me make two methane molecule itself. Here is one methane. I'll make two methane molecules. And see here. Yes. Now see here. This is one methane and the other methane. You hold it in any way, that will be a mirror image of the other one. Now what is meant by superimposing? See here. Put one above the other. See this? These two hydrogens are up. These two hydrogens are on the same side. These two hydrogens are on the same side. And these two hydrogens are on the same side. So these are not superimposable. Okay, now let me remove one of the hydrogen from each of this. I will remove one of the hydrogen and put a methyl group here, a chlorine here. This is a chlorine. Okay, now let me draw a mirror image of this. Now I will show you a mirror image of this. See here, are they mirror images? That means I have a mirror in between these two. So if I keep this in front of the mirror, the image will be this one. Agreed? Now the question is, are they superimposable? What you have to do is bring the two chlorine identically. See here, two chlorines are pointing towards the same side. Now observe the other groups. See, all of them are pointing. These are two hydrogens, these two hydrogens, these two hydrogens. They are pointing identically, right? Okay, so that is also not superimposable. Let me remove one more hydrogen. And put another group. Also. I remove one more hydrogen. and put one more group. See here, this is a chlorine, this is a bromine, and you have two hydrogen. Okay. Now this is the mirror image. Let me make the mirror image of this. See here. This is the mirror image of it. Okay. Now see whether I can superimpose them. How do you superimpose? Bring the identical groups in the same direction. See here. I bring the identical groups in the same direction. Which are the identical groups? Two hydrogens. So I have, see, these two hydrogens are in the same side. And these two hydrogens are in the same side. Okay, now observe the other two. Now see here. The other two are in opposite, are in the same direction, right? The other two are also in the same direction. Okay? The other two, even if you are keeping like this, now you are keeping these two hydrogens in the same direction, but the other two are opposite. But you can rotate it and get to the same one. See here. You are free to rotate the molecule. One second. Yeah. See here. See all the two hydrogens are same side. This bromine and chlorine they are also same side. So this is also superimposable. So how do you superimpose? Bring two identical groups in the same direction and see what is the fate of the other two. Bring two identical groups in the same direction and see what is the fate of the other two. If the other two are also in the same direction, the molecule is superimposable. Now let me remove one more hydrogen and see what is going to be the situation. So I have removed one more hydrogen and I am putting a very big group over here, iodine. Now see here. Now see here. Let me make them what is that? Mirror image of this. I have to make the mirror image. So this is the one. Are you able to see it? Yeah. Now I have to put my group here. Now see. No, not this. It's wrong. Let me see. I have to put the hydrogen on the top. Hydrogen on the top. And then, yes. Now, yeah. Now see, I have to make the mirror image of this. This should be pointing towards you. This should be on this on the right hand side, left hand side should come to the right hand side. See here. Now look carefully. Look carefully at both of them. Are they mirror images? Observe. Are they mirror images? That is what you have to see. See, these two big iodines are towards you. The H, see here. That chlorine is green. They are mirror images. And you have the two bromine here on the back side and hydrogen on the top. Now let me try to superimpose them. Let me try to superimpose. How do you superimpose? Bring two groups identical. Bring two groups on identical side. See, I'm holding the hydrogen to the upper side. I'm holding the hydrogen up. See here, carefully. I'm holding the two hydrogen and bringing this red one to the side. See here. Now see, my both the hands are holding identical groups. This is bromine I am holding, hydrogen I am holding. Now, look at the direction of the other two. See here. Unfortunately, they are not matching. Green is chlorine, and chlorine is matching only with chlorine is in the direction of the iodine in the other molecule. Okay, now let me try a different way. Let me see. Okay, now see here. These two bromines are pointing up. These two iodines are pointing to the side. They are matching. But look at the other two. Oh, unfortunate. See here. H and the chlorine is on one side, and H and the chlorine is on the opposite side. So you do whatever with this. Rotate it in any direction. Rotate these molecules in any direction. They are non-superimposable. Therefore, these two are non-superimposable mirror images of each other. And they are two different molecules. They are two different molecules. And these molecules are known to be enantiomers, non-superimposable mirror images of two organic molecules are known as enantiomers, non-superimposable Okay, we will continue the class for another 20 minutes after this, right? Okay. So please rejoin once it is over. So non-superimposable, superimposable mirror images of an organic molecule are known as enantiomers. Enantiomers. Okay, so non-superimposable mirror images of organic molecules are enantiomers. Now let me draw that. And what is the condition for that? What is the condition? It contains a chiral carbon. Because it contains at least one chiral carbon. It contains chiral carbon. Now, what is a chiral carbon? A carbon with four different atoms or groups. Atoms or groups. This is what is called a chiral carbon. Okay, so this is the basic condition of chirality. A carbon with four different atoms and groups is known as chirality. So this is the second criteria, chirality criteria. Okay, number one. This one we have already seen. See, this is the condition for chirality 1. Here I have written here. Any molecule which is not having a plane of symmetry, axis of symmetry, or center symmetry. That is chiral. Okay. So how to check chirality? How to check chirality? How to check chirality? How to check whether a compound is chiral or non-chiral? Asymmetric or symmetric? Chiral. See whether it's having a plane of symmetry. See whether it has a plane of symmetry. Center of symmetry or axis of symmetry. Number two, if this is not, you can do this way also, whether it contains a carbon, whether it has a carbon with 4 different atoms or groups. This is how you can check whether a carbon is chiral or not. So once you have this, the compound is going to be chiral. And such chiral compounds will show optical activity. Chiral compounds will show optical activity. Now let us draw the molecule. See here, carbon, a chlorine on the top. On the side, I have a bromine. And here, I have the iodine. And I have the hydrogen. You know how to draw this. Now draw the mirror image of this. We are going to play with this molecule a lot, please. I'm going to ask you to draw see the mirror image. Look very carefully at the mirror image. Cl. I. H. Okay. So this is the mirror image of it. You now do one thing. Try to superimpose them. Okay. Now I'm asking you to. We will try to superimpose on the paper. Now try this exercise. Keep on doing in your paper. Along this axis. Along this axis. What is the meaning of along this axis? You assume you're putting a